Okay, this is year 13 PPE and it's the Pure Mathematics paper 2. Okay, first question. Now we have here 4 terms in ascending powers of x, the binomial expansion of that. And what I'm going to do before I write it out is just call this thing f of x. Okay, so it saves me having to keep writing it over and over again. Okay, so f of x equals that, and I'm going to carefully, step by step, expand it out. So the first thing I do is say f of x equals, okay, and I'm using or referring to the formula in the formula book to remind me if I need to. So in this case my n is a half and my x is actually 9x. So it's 1 plus a half of 9x. Okay, and then I've got a half times negative a half. Okay, and that's n minus 1, you see, times the square of my x, which is the square of 9x, and all of that is over 2 factorial. Okay, and the last term I'm interested in is going to be n minus 1, then it's n minus 2, and all of that is multiplied by the cube of 9x. Okay, and that's all divided by 3 factorial. Now I strongly encourage you to write down in full the first stage like that, not try and take shortcuts as you go, because invariably you make an error with one of the minus signs or something and the whole thing goes wrong. And I normally just say afterwards plus ... just to show that it does continue, but we're not going to go any further with it. Okay, now you can use your calculator at this point and enter the terms in simpler form, and that does give you 1 plus 9 over 2x. Okay, I wouldn't put these as decimals, I would leave them as fractions like this. 81x squared over 8. Okay, 81x squared over 8. And one more term, and that actually comes out to be plus 729 over 16. Okay, and that's multiplied by x cubed. Okay, and that's what you need to do to answer part A of the question, and then it just continues on from there. Okay, so that's your first 3 marks, and your next 2 marks come from part B, where you've got to explain how you could use that in the expansion to find this. Well, the best way of doing this is just to actually see what happens when you put it in and then explain. So I'm going to write 1 plus 9 lots of 1/36, which is 9 over 36, okay, to the power of a half. Okay, and that of course is 1 plus a quarter, and that's therefore 5 quarters. 1 plus 1 quarter is 5 quarters to the half. Okay, and that in turn is equal to root 5 over root 4, which of course is root 5 over 2. Okay, so now you can see that what would happen is if you used 1/36 as x, it would actually give you an evaluation of or an approximation of root 5 over 2. So what you would need to do is you would need to substitute x equals 1 over 36 into f of x, and then multiply by 2. Okay, and that's key. If you don't put that multiply by 2, then you're not really understanding the problem. Then multiply answer or result by 2. Okay, that's it. Next question. By taking logarithms of both sides, solve that equation, giving the value of p to 1 decimal place. Now, you could look at taking logs to base 3 or logs to base 5. To be honest, with a question like this, the best way to approach it is just to use natural logarithms. And I would just do the natural logarithm of 3 to the power of 3p plus 1 equals the natural logarithm of 5 to the power of 39. Okay, and then I would use the rules of logs, so I would put the 3p plus 1 to the front, so 3p plus 1, okay, in a bracket, times the natural log of 3 would give me 39 times the natural log of 5. Okay, and then I just need to rearrange it and get p on its own ultimately. So I need next to do 3p plus 1 equals 39 log 5. Probably good to leave a small gap there between the 9 and the log, otherwise it looks like 391. Okay, 39 log 5 over log 3. And then, of course, I just need to subtract 1 and divide by 3. And just be careful, because you've got to take 1 from all of that and then divide the whole thing by 3. So it's probably best just to write it as I would go next to p equals 1/3, okay, of all of this. Okay, I'll just make a copy of it. All of that, and then minus 1 afterwards, and that will need to go in a bracket, of course. So it's 1/3 of that minus 1, and then you just put that into the calculator, and that comes out to 1 decimal place to be 18.7 to 1 dp. Okay, next. Now, this is quite an interesting little question about functions, because you could do it an easy way, or you could do it in quite a difficult way. The first thing you've got to do here is find the inverse function of 6. So the best way to do that, because you don't even need to work out what the inverse function of x is, you can just set f of x equal to 6 and then solve it. Okay, and that's a lot quicker than working out the inverse function of f by rearranging it all. So all I would do for part A is just say that f of x equals 6, so therefore 3x minus 7 over x minus 1 equals 6. Okay, and then just rearrange that and solve it. Okay, so that gives me that 3x minus 7 equals 6x minus 6. I can take away, let's take away 3x from both sides and add 6. So that would give me minus 1 on the left, and that equals 3x on the right, and therefore x is going to be minus 1/3. Okay, and that's it. And I'll just confirm it by stating at the end that that is the same as f to the minus 1 of 6. Okay, because I hadn't actually stated that explicitly here, but it was implied in what I'd done. So I just underline that last part to show that I've answered the question there. Okay, and then I have to show that f of x equals that. So I know that if I do my algebra carefully, it's going to look something like that. So let's see how we would go about that. Now, to start with, it looks quite cumbersome, and you've just got to be very focused on your processing of algebraic fractions. So f of x means that you take the function f of x, and wherever you see an x, you replace it with a copy of f of x. So basically, it's going to be, instead of 3x minus 7 on the numerator, it's going to be 3 lots of the function 3x minus 7 over x minus 1. Okay. So you've got these fractions within fractions, and then from that you've got to take away 7. Okay, and then underneath that you've got to do the same sort of thing again, because you have another occurrence of x, and underneath that you're going to have well, a copy of this part here. Okay, that's the x, that's replacing the x, and then from that you've got to take away another 1. Okay, now the key thing to do here is to put a common denominator of x minus 1 throughout the numerator and throughout the denominator. So if I was doing this in full, I would be rewriting this. Perhaps it's better if I explain it like this. If I just took this 7, let me write it again. It's probably easier just to make another copy of the whole thing. So basically, I can more or less copy that thing as it is. Okay, so let me just take the whole thing across, make another copy of it. Okay, but on this second copy, I'm just going to work on it a little bit. So I'm going to take that 7 out there. Okay, and I'm going to replace it with 7x minus 1 over x minus 1. Okay, so I've just put a common denominator of x minus 1 within that numerator. Okay, and then this one, I'm going to do the same sort of thing to that. So that one's going to be replaced by x minus 1 over x minus 1 as well, you see? And then I can just quite simply take out all of the x minus 1s that appear on the bottom of these fractions. Okay, and I would show some steps of working like I've done there, just to make it clear what you've actually done. Okay, because there's quite a lot of changes have been made to that. Now, that means that I can just go straight now to this statement, that I've got 3 lots of 3x minus 7, which is 9x minus 21, and then I've got to take away 7x minus 1, but it's take away 7x and take away minus 7, so it's going to be plus 7. Okay, and then underneath that I'm going to just have 3x minus 7 minus x plus 1. Okay, so 3x minus 7 minus x plus 1. If I put all that and tidy that up, I get 9x minus 7x is 2x, and I get 2x minus 14, and that's all over 2x minus 7 plus 1 is minus 6. So it's 2x minus 14 over 2x minus 6, and hopefully you should be able to see straight away that that can be written as x minus 7 over x minus 3, which is the answer to the question because it's in the form x minus a over x minus b. Okay, so that's it. So it works out quite nicely. Now, interestingly enough, if you did do the inverse function of this earlier, you would have found by coincidence that it's also x minus 7 over x minus 3. Okay, but that's the answer to part B, and that's how you get those 3 marks. Okay, next question. Now, a slightly unusual question, this one, because you don't actually need to work anything out. You just need to write down an equation. But what you were supposed to recognize here was that the rate of increase of n is proportional to n. So for 1 mark, if you had just started by writing that the rate of change of n, which is dn by dt, okay, is proportional to n, that would have got you off the ground with 1 mark. Okay, and from then you could have gone on to say that because you've got to give a suitable equation for n, you could say that n is some constant times dn by dt. Okay, and we were allowing that for the 2nd mark because you haven't fully learnt about differential equations yet. However, you have learnt about the differential of e to the x being e to the x. So let me just explain what I mean. If y was the function e to the x, okay, then the differential dy by dx is also e to the x. E to the x is the only function whose differential is the same as the function itself. But if you had, for example, e to the 3x, okay, and you differentiated that, you would take the differential of the 3x, which is 3, put it in front, and it would give you 3e to the 3x. And if you had something like e to the 3x plus, let's say 2, okay, the dy by dx for that would be this. It would be the differential of 3x plus 2, okay, which is just 3, e to the power 3x plus 2. Okay, and that could then be written as 3 times e to the 3x, okay, times e squared, okay, using the power, the rules of indices. Okay, now e squared, 3e squared, could be some constant. Let's call it a. So if I said let 3e squared, because that's a number, you see, 3e squared equals a, then I would have that dy by dx is equal to, in this example, it would be 3, it would be a e to the 3x, you see. Okay, and that is the form that these equations take, and you've used them in several questions about exponential growth. Okay, and so what you were supposed to go on to do with that was to write something like that. So n equals some constant a e to the power of kt or ct or something like that, would have got you the 2 marks as well. So we were quite lenient on marking that as long as we saw something like this or this in your answer. Okay, And this stuff here was just an explanation or an example of what happens when you differentiate e to a function of x. Okay, next question. Okay, question 5. Now, in this question, you were given some information about this curve C and a region R that's formed between the curve and the straight line L. Okay. Now, when you look at this, first of all, you're immediately drawn into thinking it's about integrating and finding the area. But in fact, it's got nothing to do with integrating and finding the area. You've just got to use inequalities to define the region R. Okay, now you've got some information about the minimum point being negative 2, 13, and you know that f of x is a quadratic. Now, there would be a temptation to complete the square and think of, the expansion of x plus 2 all squared plus 13. Okay, but that isn't going to help you in this case, because you'll find that you won't get the constant crossing at 25, because the general form of this will be ax squared plus bx plus c. So this is what I would do for this question. I would say let f of x equal ax squared. So I'm making a general quadratic. F of x equals ax squared plus bx plus c. But I don't have to put plus c, because I know that the plus c would be plus 25. So I can go straight to putting that value in. So there's now two unknowns, which are, of course, a and b. Okay, so that's the first thing I would do. Now, going on from that, I would work out the derivative, okay, f dashed of x, and that's going to be 2ax plus b, okay, and I know that that's going to equal 0 when x equals negative 2. Okay, because in the question it tells me that at the point when x is negative 2, it's a minimum point on the graph of f of x. It's a turning point. There it is. Okay, so I can use that information to write an equation linking a and b, you see, straight away. So 2 times a times minus 2, so that's minus 4a plus b equals 0, which means that b is the same as 4a. Okay, so that's going to be useful in a moment. I'm now going to consider what happens in the general function f of x at the point minus 2, 13. So at minus 2, 13, okay, so at the point negative 2, comma 13, I can say that 13, that's the y value, equals a times negative 2 squared, which is 4, plus b times negative 2 plus 25. Okay, but I know that b is the same as 4a, so I can say that 13 equals 4a minus 8a, because I'm replacing this b here with 4a, plus 25. Okay, which means that if I now were to take away the 13 from both sides, I would get 0, or perhaps better if I took away the 25 from both sides, I'd get minus 12 equals minus 4a, and that means that a must be 3, and because b is 4 lots of a, b must be 12. Okay, so that way I now have found that my quadratic f of x for sure is equal to 3x squared okay, plus 12x plus 25. Okay. And the other thing I've got to do now, I've now established what f of x is. The equation of the straight line that goes through the points 0, 25 and negative 2, 13, I can just say, well, the gradient of that is clearly going to be 25 take away 13. So if I just work on L now over here, so for L, okay, I can say that 25 minus 13, okay, and I need to divide that by the difference in the x coordinates, which is minus 2 to 0, which is 2, okay. That equals 12 over 2, which is 6, okay, which is equal to gradient of L, okay. And it cuts the y-axis at 25. So L is the line. So L is such that y equals 6x plus 25. Okay. So what I've got to do now is I've got to define that region using inequalities. So basically the curve, which is 3x squared plus 12x, okay, plus 25, is below y, okay, which is also below 6x plus 25. Okay, so the region R that's shaded is in between those lines. Now, there's a question as to whether it's including the lines or not. Okay, they're solid lines, so you can include them as well. Okay, and that's defining the region which is shaded there. Okay, and in the mark scheme they do accept whether or not you use equals as well as just less than. Okay, but you can present it as a single inequality between those two limits like that. Okay, question 6. Okay, so here we have two circles, C1 and C2. We've got their equations. We can see that they overlap here, and we're to work out ultimately the perimeter of this shape. Okay, now before we do that, we've got to show that this angle AOB is equal to this value here. Okay, so I'm just going to draw in that angle AOB. Okay, and we can see it's symmetrical horizontally through the middle, through the x-axis. And we're also going to need to use the center of this circle as well in the problem when we come to do the arc lengths for part B. So I'm just going to put that in as well. So that's supposed to be the center of the circle there. Okay, so what I'm going to do is first of all find the coordinates of the points A and B in order to find the intersection of the circles. Okay, so I'm going to start by writing that if x squared plus y squared equals 100, okay, then it follows that y squared can be written as 100 minus x squared. Okay, I'm going to substitute that into the equation for C2. So for C2, I'm going to take the x minus 15 and square it. So that's going to give me x squared minus 30x plus 15 squared, which is 225. okay, and then I've got to add on to that y squared, which we've just stated as being the same as 100 minus x squared, okay, and that is equal to 40. Well, immediately the x squareds cancel, okay, and you are left with, if we bring over the 40 and move everything across, we get minus 30x equals minus 285. Okay, the x squareds have gone, and that tells us that x is therefore 9.5 or 19 over 2. Okay, so I'm now going to say that if x is that, what's the value of y if the y coordinate of the point A? So if I substitute that in for y and into this equation, which implies that y would be the square root of, okay, 100 minus 19 over 2 squared. Okay, and we can get that as an exact surd off the calculator without needing to evaluate it numerically, and it comes to root 39. Okay, root 39 over 2. Okay, so that's the exact y coordinate of the point A, and the x coordinate is 9.5. Okay, so we've got that far. Now, the angle AOB is 2 lots of the angle just in here. So if I just do an enlarged diagram of the triangle OA down to the x-axis, okay, it's a bit easier to see what's going on then. Okay, so that gives me a right-angled triangle with a base of 19 over 2, okay, and a height of root 39 over 2. Okay, this is the point O, this is the point A, and this horizontal line is the x-axis. So the tangent of that angle there, okay, is opposite over adjacent, which is root 39 over 19. All right, so the angle AOB, okay, so angle AOB is going to be double that. Okay, so it's 2 lots of the inverse tangent of root 39 over 19. Okay, we don't need the 2's because they effectively cancel out. Okay, and that comes to 0.635 radians. Okay, 635 radians, and that was what we had to prove or show. Okay, so that's the first part of the question done. Now, to find the perimeter of the whole shape, I'm going to consider not the angle inside that I've just worked out, but the angle outside. Okay, because the length of an arc, when the angle's given in radians, is r, the radius, times theta. Okay, and we need to work out what the 2 different angles are. This one in the middle here, and this one here is a slightly bigger angle. Okay, so the angle on the outside is going to be 2 pi minus the angle on the inside. Okay, so that's the angle I'm interested in around there, and I'm also interested in that angle around there. Okay, now I'm just going to do another one of these triangles for here, okay, to illustrate what's happening here. I'm going to call this point in the middle of the circle here P. Okay, so I'm just going to do another triangle to show A. So this is A, and that's P, okay, because that's a different angle, and I'll show you how that's going to be useful in a moment. Okay, let me just try and improve that a little bit. That'll do. Right, okay, so what we're saying now is that we've got, that's the point P down there, okay, this is from the smaller circle, this is the point A, okay, and we need some lengths on here. Just put a right angle in there as well. So we know that this height here is the same, that's root 39 over 2, okay, that hasn't changed, but what has changed is this distance here. You see, this point here, P, is the point 15, has an x-coordinate of 15, okay, because of the equation of the circle. Now, we know that circle C1 has a radius of 9.5, okay, so that leaves us with 5.5. So this distance here is 11 over 2. Okay, 11 over 2, 5.5. So because if you add that to our 19 over 2, you get 30 over 2, which is the 15, the distance between there and there. All right, so that's going to be useful because I can now work out what this angle is using the same kind of technique I've used up there. All right, but what I'm interested in for part B, so this was all part A. Okay, so for part B, what I'm interested in doing now is I've got the angle around the outside times the radius, okay, and the radius is 10, okay, so 10 times the angle around the outside, which is 2 pi minus this thing I've just worked out, but I'm going to write it exactly as 2 times the inverse tangent of root 39 over 19, because that's the exact value. Okay, and if you can store that on the calculator and use it, it's better. Okay, so it's that plus, okay, the arc length in yellow around C2, and that's going to be the radius of that, which is root 40 from the equation of the circle, okay, times the angle, which is 2 pi minus 2 times the inverse tangent of the new angle here, which is root 39 over 11, okay, because it's a different angle, like that. Okay, now that's it. That is the calculation that you need to do. All right, and if you put that into the calculator as it is, and you're careful about entering it, that gives you the angle, or rather the length of the two yellow arcs added together, which comes to 89.7 units. Okay, just put units because we don't know what the measurements are in. And then just qualify that by saying 2,3 SF. Okay, 3 significant figures. Well, it actually says give it to 1 decimal place, but it amounts to the same thing. So, okay, now you could have done that by working out the 2 minor arcs. They're the ones inside the circle, and then subtracting them. And that would be a perfectly acceptable way. Okay, but if you are going to do something like this, just be very careful to set everything out clearly before you reach for the calculator. Okay, next question. Okay, this trig question, slightly unusual, because when you first look at this, you could be thinking, I need to use the addition formulae here. And you don't, in fact, need to. It is possible to do it that way, but that actually takes quite a long time. There's a much simpler way of doing it, and the first thing is to show that statement is true. So when you do these kinds of proofs, choose to start from either the left or the right and work either backwards from the right or forwards from the left, rather than just meeting somewhere in the middle, which is not really a good practice. So what we're going to do here is we're going to say from the left hand side, so I'm going to actually write LHS, which is an accepted abbreviation for left hand side. I'm going to write the cosec as, by definition, 1 over sine. Okay, so 1 over sine theta, okay, minus sine theta. Now don't say that that equals this, because that's what we're trying to show. We can't just use that now. We've got to leave that alone, and hopefully we arrive at that at the end. Okay, but what I can say is that that is the same as 1 minus sine squared theta all over sine theta. Okay, now be careful about missing out too many steps. Okay, what I've done effectively is put a common denominator of sine theta in here, okay, and then combined it into a single fraction. And now I'm going to use the identity that 1 minus sine squared is cos squared. Okay, so cos squared theta over sine theta. Okay, which is a third step. And I'm going to split the cos squared up into cos theta times cos theta over sine theta. Okay, in other words, I'm starting to make this look like the result on the right, and I'm just putting the sine theta underneath this part. Okay, because hopefully now you can see that I have cos theta times 1 over tan, which is the same as cos theta times cot theta. And at that point, I would go into cos theta, cot theta, which is equal to the right-hand side. Okay, so I've moved from the left-hand side to the right-hand side in several steps, clearly showing what I'm doing. Make sure you can justify the 3 marks, okay? Don't try and go too many steps at once. Don't go straight from there to there. It's too big a jump, I think. You need to show some steps, okay? And hence or otherwise solve this equation. Now, when it says hence or otherwise, it normally means hence, because based on what you've just done, this should be easy if you use what you've just done, okay? So this is what you need to be careful of here. And remember, you can use your graphics calculator to show you the solutions, but you still need to show how you get them, okay? So you can use it as a backup. You can look at the graph, you can see how many there are, and you can make sure that you produce the algebra to find them, all right? So the first thing I would do for part B is this. If this is true, okay, and this is true, then clearly one solution is that x must equal 3x minus 50. Okay, it is almost too obvious, and of course you could then follow that on to say that therefore 2x is 50, okay, and therefore x is 25, which is indeed one of the solutions. okay? And that's perfectly okay. But the risk is there that you think that's it. And if you've got your graphics calculator, you would see that it's not. Now, what really you should do is a bit more sophisticated than that, okay? And what I'm going to do is write it out a bit more fully so that we can see where the other solutions come from. And you might have chosen just to go straight to this. So I'm going to say that cos of x times the cot of x, okay, using the right-hand result, minus cos of x times the cot of 3x minus 50, okay, must equal 0, because basically I'm setting the cos x cot x equal to cos x cot 3x minus 50. So if these two are equal to each other, then if we subtract them, we get 0. Now, you might be thinking, well, why do that? Well, I can now factorize out the cos x, you see, and then put the cot x and the minus cot 3x minus 50 together like that. Okay, and now you can see that one solution is that cos x equals 0 as well. Okay, so from this I still get my solution that x is 25, but I also get that cos x equals 0, okay, which implies that x would equal 90. Okay, I'm just going to highlight that as another solution. Okay, and it would be very easy to miss that one if you just did purely what I've done up here. Okay, so I could have gone straight to this and done that and that from this part here. But there's another solution, and if you were to put this on the graphic calculator, you would see that, okay? And what I'm going to do is I'm going to consider now that the cot graph, like the tan graph, repeats every 180 degrees. So if cot of x equals cot of 3x minus 50, then I can also say that cot of x plus 180. Okay, so I've also got cot of x plus 180 degrees is also equal to the cot of 3x, okay, minus 50. And if I solve that one, I get that x plus 180, okay, x plus 180 equals 3x minus 50. Rearranging that gives me 2x equals 230. Okay, 2x equals 230, and therefore x equals 115. Okay, 115 degrees. So what I've done is I've actually found three solutions, and there are three solutions. And if you did put that on your graphic calculator, looked at it between 0 and 180, you would see those three places where this equation is solved. So you can just summarize by saying x equals 25 degrees, comma 90 degrees and 115 degrees. Okay, and that's it. We tend to list them in ascending order. I mean, you don't have to, but it's generally the way that we do it. Okay, so an interesting little problem. It doesn't matter what order you find these solutions in. The main thing is to make sure that you find them all. Okay, and next question. Now, in this question, we have a sequence of numbers, A1, A2, A3, and so on, defined by this recursive relationship, okay, which means that the next term is generated from the previous term. Okay, so we're told some basic information that the first term is 2, and the sequence is periodic of order 3. So that means it repeats every 3 terms. So it goes sort of x, y, z, x, y, z, x, y, z, and so on. Okay, so we've got to show that this statement is true. Show that it's true for 3 marks. So we need to do some working out. So I'm going to start by saying, right, well, we know A1 is, I'll do it from here, I think, so I've got space. A1 equals 2. Okay, we're given that. Now, to get A2, okay, we know that A2 is equal to K times A1 plus 2, okay, just using this here, divided by 2. Okay, and if we work that out, that comes to 4k over 2, which is simply 2k. Okay, and we can work out that A3 uses the previous value, which is 2k, so it's k times 2k plus 2, and all of that is over the previous term, which is 2k. Okay, immediately cancel out the 2k's, the k on the top and the k underneath there and there. That gives you 2k plus 2 over 2, which is the same as k plus 1 over 1. So that just simplifies to k plus 1. Okay, and then A4 is going to be, well, that's going to be k times k plus 1, okay, which is this part here. Okay, the AN is k plus 1 plus the 2, okay, and that's all over k plus 1, which is the same as A3. Okay, but we also know that A4 is the same as A1 because of the period of 3, so it's also equal to 2. And now we just have to rearrange this equation here, okay, and we get that k squared plus 3k, if I multiply that top bracket out, k squared plus 3k is equal to 2 lots of k plus 1, if I bring that up to the right. Okay, multiply that out, you get k squared, okay, plus 3k, take away 2k, and take away 2 would give me 0. And just combining the middle two terms, I get k squared plus k minus 2 equals 0, and that's as required. Okay, so you need to put in sufficient steps to justify those 3 marks. So don't be tempted to go missing out too many steps. Okay, so that was part A of the question dealt with there. Okay, I'll just put part A up here like that. Now, for part B, it says explain why k cannot equal 1. I'll do part B in this space here. Okay, right. Let's assume that k did equal 1. Then what would happen? A1 would equal 2. We know that already. A2 would equal 2 times k, which is 2 times 1, which is 2. And A3 would equal k plus 1, which is 1 plus 1, which is also 2, etc. So if A1, A2 and A3 all equal 2, we know A4 is equal to 2. All the terms would be 2. So all terms 2, all terms equal 2. And that means, therefore, that not periodic of order 3. Okay, because we're told that it has to be periodic of order 3. And if it's just a string of 2s, then it wouldn't be. So that's what they'll be looking for in that answer. Okay, so next for part C, we have to show that we have to find the value of this sequence here. Now, this series rather. Now, what we're going to do is recognize that if we've got 80 terms altogether, we can group them in 3s, okay? Because every 3 terms will be the same. And we're also going to need to know the value of k. So I'm just going to solve this quadratic here as well. I'm going to do that first, actually, because we need to know what k is to work out what the values of these first 3 terms are. So k minus 1 and k plus 2 equals 0 if you factorize it, okay, which implies that k equals 1 or minus 2. Well, we know it's not 1 because we've just explored that, but we know we need to use the minus 2. So therefore, A1 is equal to 2. We know that already. A2 is going to equal to, well, it's going to be 2k, so it's going to be minus 4. And A3 is going to be k plus 1, so it's minus 2 plus 1, which is minus 1. Okay, so those are the first 3 terms in the sequence: 2, minus 4, minus 1. And then it repeats 2, minus 4, minus 1. Now what I'm going to do is I'm going to say that if I do 80 divided by 3, how many groups of those 3 numbers can I get into the 80? So 80 divided by 3, okay, that gives me 26 with a remainder of 2 terms. Okay, that will take me up to the 78th term, you see. So I'm going to have, so the sum from r equals 1 to 80 is going to equal of that is going to equal 26 lots of the first 3 terms added together to minus 4 minus 1. That will take us up to the 78th term. The 79th term is going to be 2, and the 80th term is going to be minus 4, you see? And if you work all of that out, you get minus 80. And that is the answer. Okay, next question. Now, this is a question about proof by contradiction. So to get the marks for this sort of question, you've got to use the correct language and processes. So prove by contradiction that there are no positive integers p and q such that that's true. So what I do first is I assume that there are positive integers that satisfy that, okay? So I assume, okay, that there exists, I'm using shorthand notation here, you can use words, assume there exists P and Q, okay, both members of the positive integers, okay, such that 4p squared minus q squared is equal to 9. So I'm assuming that they do exist. And from that equation there, it follows that if that were true, then it's the difference of two squares, and you need to spot that in order to answer this question. Okay, 2p plus q is equal to 9. Now, if you think of the factors of 9, okay, I'm just going to make a note of this. The factors of 9 are 1, 3, and 9, okay? And we've got a factorization here, two numbers to multiply together to give 9. So it follows that 2p minus q could be equal to 1, and 2p plus q, okay, could be equal to 9. That would be one set of solutions, because 1 times 9 is 9. I'm just going to take out that unnecessary bracket there. Okay, so that's one possibility. Okay, the alternative, I'm just going to put or here. Okay, and that is that 2p minus q equals 3 and 2p plus q equals 3, because 3 times 3 is equal to 9. All right. Now, if we take the first example, that would mean that if we tried to solve those two equations simultaneously, we would add them together to eliminate q, and it would give us that 4p equals 10, which would imply that p equals 2.5. Okay, and if p is 2.5, q would have to equal, well, it would be 2 times 2.5 is 5, minus 4 would have to be 1. So q would have to be 4. Okay. Now, we look at the other scenario here, and we have this situation. Okay. And if to eliminate q here, we add them together again, and we would get that, well, 2p plus 2p, 4p would have to equal 6. Okay, which means that p would have to equal 1.5. Okay, and q would have to equal 0. So what we've done is we've solved the equation simultaneously, and in each possibility, each case, we've shown that p would not be an integer. Okay, so that's the mathematical part of it and the algebra. We've shown that in both cases p is not an integer. So what I'm going to do now is bring in the conclusion. I've written it, typed it out here. It saves a bit of time, because you need to get used to the sorts of words they like to see in the conclusion. So this is a contradiction, as there are no integer solutions. Hence, there are no positive integers p and q, such that this thing here is true. So such that 4p squared, okay, minus q squared equals 9. Okay, and that's the way that you would get those 4 marks in that sort of question. Okay, next question. Okay, we have here in question 10 an integration to do. Okay, we're given the velocity as a function of time, and we're told even that the the distance s is given by the integral of that, which of course it is. So let's just go about integrating it. We need to show sufficient steps to justify the 5 marks. Okay, so s equals 1/15. Okay, and I'm going to go through term by term and integrate as we move through. So it's t to the half, okay? The integral of that becomes t to the 1/2 divided by 1/2, which is the same as timesing by 2/3. So it's 2/3 of 45, which is 30. Okay, t to the power of 3/2. Okay, and then we've got to add on to there 20 t cubed over 3. Okay, and then finally we've got to take away t to the power 4 over 4. Okay, so use the correct notation, and remember now that we've got to close the square bracket and include the limits. And also, of course, remember that we do not need to put the constant of integration on a definite integral. So the upper limit is 20 and the lower limit is 0. Okay, so we now go to the next stage, which is to substitute those values of t in. Okay, and that will give us that s equals 1/15 of, now it's going to be, put the square brackets in again, so it's going to be 30 times 20 to the power of 3/2, okay, plus 20 times 20 cubed over 3, and then we've got 20 to the power 4, and that's all divided by 4. Okay, so just be careful to use the same form, make the substitution clearly, and from that's for the that's with the 20 in, and then I'm going to take away the same thing with a 0 substituted. But given that every term is going to be 0, I think it's reasonable just to put the 0 in there as a single item like that. And then we just have to evaluate that on the calculator. Now, I suppose at this stage we've probably got sufficient enough working to do that. So if you carefully put that in the calculator as it is, you could you put another line in if you wanted to, but I'm just going to go straight to the calculator answer. And I would write down, first of all, the unrounded version. So it comes to that, and then some more things after there, and then give that as your final answer to 3 significant figures, which it requires as 1070 meters, like that. Okay, so it's just over 1 kilometer that it travels in those 20 seconds. That seems quite a long way, but you know, these roller coasters these days go pretty fast, so that's quite possible that it would cover that in 20 seconds. Okay, next question. Now, this question, quite an unusual one about circles. We're talking about this circle C with a radius of r that's lying in the first quadrant, okay, and it's touching the x and y axis, okay. Now, what that means is the center of this circle must be at the point r comma r, all right, for that to be true. I'll just make a note of that here. Okay, so whatever the radius of the circle is, that's how far along and up it needs to be from the origin, you see. Okay, and we also have this line L with equation 2x plus y equals 12, which we're going to rearrange to tell us that y is 12 minus 2x. Okay, And what we've got to do first is show that the x-coordinate of the points of intersection of L with C satisfy this equation. So I'm just going to put some algebra down. I'm going to start with the equation of the circle, which is going to be this. You see, it's going to be x, let's put question A there. So it's going to be x minus r all squared, okay, plus y minus r all squared. And that's going to equal the radius squared, which is, of course, r squared. So we need to expand all that out, and that will give us x squared minus 2rx plus r squared. Then it's going to give us y squared minus 2ry plus r squared. And all of that equals r squared. Okay, now we can replace the y with 12 minus 2x, and we can also cancel out these two r squareds here. Okay, so we're going to have x squared minus 2rx, okay, plus r squared, plus, now we're going to have 12 minus 2x all squared, okay, for that y squared there. Then we're going to have minus 2 times r times y, which is also another 12 minus 2x, okay, plus r squared equals r squared. Cancel those out, that will just give me that. Okay, so I've now removed the variable y, and I'm looking for an equation that contains r and x, so that's what I'm doing here. I'm trying to eliminate this y term, so I've done that now. Now I just need to hopefully get this to look like this. So let's see what happens. And I noticed the way they've done it here, they've grouped they've got the x squared term there, the x coefficients here, and the numbers which don't contain x here. So I'm going to try and do the same thing. So I'm going to put all my x squareds together. Okay, so perhaps another expansion of all of these brackets is needed first. So quite a bit of algebra to do here beforehand. Okay, now this thing here is going to give me 12 squared, it's 144, okay, minus 48x plus 4x squared, okay. So that bit there is just the expansion of this bracket. Then I've got minus 24r from here, and I've got plus 4rx. Okay, equals 0. Now hopefully that will give us what we've got up here. So x squared and 4x squared, I see, will give me the 5x squared. Okay, so I've taken care of the x squared terms. Now we're looking for the x terms, and I've got a minus 2r, okay, and I've got a plus 4r. So between those two, that gives me plus 2r, and I've also got a minus 48. So I do indeed get plus 2r minus 48, lots of x there. Okay, and then I need the numbers, which hopefully are the bits that contain either numbers or the letter r, but no x's. And of those, I've got an r squared somewhere on its own. Okay, there it is. I've also got a minus 24r and a 144. So it all works out. Okay. And just to keep it like the example up here, I'm just going to put some brackets around that part as well. Okay, so step by step I've shown that this equation here is true. Okay, 3 marks. Given also that L is tangent to C, find the 2 possible values of R, giving your answers as fully simplified surds. Now, this is a little bit more difficult to understand because when you visualize this, you think of this line here as passing with the circle to the left of it. I'll show you what I mean. I've done a couple of graphs and that will show you the 2 possibilities, because you might not be able to think of them both. So what I've got is that possibility there, okay? But the other option is that the circle is to the other side of the red line completely, like this, a much bigger circle, you see. So you can use your graphics calculator to help you visualize the possibilities there. So we're looking at those 2 situations and what the values of R are to satisfy each of those cases. Okay, and we use the classic discriminant, setting that equal to 0 in the quadratic. Okay, and you should be familiar enough with that by now. So let me just scroll this up a bit so we can work in the space below. Okay, so we've got that, all the information we need there. We've looked at the 2 possibilities. So what we're going to do for part B, first of all, okay, I'm just going to say b squared minus 4ac equals 0. Okay, b squared minus 4ac equals 0. Now, because we haven't used those variables, I'm just putting that sort of in speech marks, because we talk about the discriminant as being b squared minus 4ac, and that's perfectly acceptable. Or you could just use delta equals 0. Okay, that's another thing you might write instead. Okay, delta is accepted to mean the discriminant. All right, so whichever of those you write down doesn't really matter. But if I take the discriminant from the quadratic, my b is 2r minus 48. Okay, so 2r minus 48 squared. Okay, that's my b squared. Okay, and minus my 4 times my a, which is 5, that's the x squared coefficient, times the c, the constant, which of course in this case is r squared minus 24r. Okay, it's all that bracket there. R squared minus 24r, okay, plus 144, okay, and that has to equal 0. Okay, now if you expand that out and simplify it, I'm just going to jump a step there, I think, just to save a bit of time. But if you work on that and simplify it, you get minus 16 r squared, okay, plus 288r, and finally minus 576, okay, equaling 0. And if you multiply everything by minus 1 and divide by 16, you get r squared, okay, minus 18r, and then plus 36. Okay, now we already know that it won't factorize because they ask for the answers as fully simplified surds. So now we can use the quadratic formula. It's probably the best way of doing that. And it tells us that r equals 18 plus or minus the square root of 324 okay, minus 4 times 1 times 36, substituting into the quadratic formula, all over 2, Okay, I'll just put the various lines in there. So it's that and that there. Okay, and if you put that in, that gives you 9 plus or minus 3 root 5. Okay, which is equal to 9 plus or minus 3 root 5. Okay, and they are indeed the two values of r which satisfy that equation. Okay, and they're the two images that we get from the graphs, which I'll just pull that down again. So that's the large circle using when r is 9 plus 3 root 5, and then up here we had the opposite situation where r was the smaller of those values, giving rise to the smaller circle there. Okay, next question. Now this curve has equation y equals f of x, and we're told some information about it, and we're not actually told the function f of x. We've got to find that. What we're told is f dashed of x, the differential, where it cuts the y-axis and one of its factors. So what I'm going to do is just start working through this stuff. So if that's the f dashed of x, then that's the derivative, then f of x is going to be of the form, the integral of that basically. So I need to integrate that, so I get 6x cubed over 3. Okay. I'll simplify it in a moment. Let me just leave it like that for now. Minus ax squared over 2. And I've also got plus 4x plus c. Now you do need a plus c here because this is an indefinite integral. Okay, and that of course can be simplified to 2x cubed minus a half a, or a over 2, times x squared plus 4x plus c. Okay, so that's my starting point. Now if x minus 1 is a factor, so x minus 1 is a factor, okay, it implies that f of 1 must equal 0 by the factor theorem, you see. So what I need to do is I need to put 1 into this function and set the answer to 0. So f of 1 equals 0, which implies that 2 times 1 cubed minus a over 2 times 1 squared plus 4 times 1 plus c must equal 0. Okay, and if that's true, then I get, if I just work that out, it gives me that minus a over 2 equals minus 7, or a over 2 equals 7, or a equals 14. Okay, so I'm starting to find out these variables. Now, we also know that the y-intercept of c is 1. So we actually know that when x is 0, that's 0, that's 0, that's 0, and it crosses at 1 on the y-axis, so c must be 1. Okay, so I could actually say here at this point that c equals 1. Okay, because that's implied in this part of the question. So I now know the value of a and I know the value of c, and that's all I need to do to complete the function. So from what I've done above, I can see that f of x is going to equal 2x cubed, okay, minus 14 over 2x squared, which is minus 7x squared, plus 4x plus 1. Okay, now of course in the exam you've got your graphic calculator. Just plot that graph and have a look at it. You should see that it crosses the y-axis at 1, and it crosses the x-axis at 1 as well, because x minus 1 is a factor. All right, so you can always use that as a backup to check. But that's the algebra that would get you the marks for that question. Okay, next question. Now this is about exponential growth or change. It's to do with the temperature of ethanol as it's heated up. Okay, and we've got some boundary information here, and we're told that theta operates according to this equation here, and we've got to find the values of the constants a and b. So what I'm going to do is I'm going to consider the initial situation when t is 0, okay? So at time t equals 0, we're told that the temperature is 18, okay? So t equals 0, so 18 is theta, and that equals a minus b times e to the power of 0, you see, which is just 1, so a minus b. Okay, so that's one equation that we have. And we're told that at t equals 10 seconds, okay, so when t is 10 seconds, the temperature has risen to 44, so it's very quick, okay, 44, and that equals a minus b times e to the power of, now if we times this 0.07 by 10, we get b e to the power of 0.7, okay, minus 0.7. So that's the sort of two equations that I'm going to solve simultaneously. Okay, so if I just subtract the two equations from each other, I'm going to get 26. Okay, 26. The a's will go, and that will leave me with b times 1 minus e to the power of negative 0.7. Okay, if I divide both sides by 1 minus e to the minus 0.7, it will give me that b is equal to three significant figures, 51.6, okay, and a is therefore going to be 18 more than b, which is that a is 69.6. Okay, and both of those are given to three significant figures. Okay, so that's where I've got to so far with that. So the next thing is to write the full equation, which is that theta equals, let me just write that down, theta equals, okay, and I've got 69.6 minus 51.6 times e to the negative 0.07t. Okay, so that's my equation that I had to form and show how I got it. Okay, for part B, we've got to evaluate the model when theta is 78. Okay, now what we've got to do is set theta to 78, and I'm going to rearrange it. So I'm going to put theta equals 78, okay, implies that, Now I'm going to subtract the 69.6, so I'm going to get 78 minus 69.6, okay, and divide it by 51.6, or divide it by minus 51.6, okay, and that gives me that. And if I work that out, that will give me a negative number. Okay, that gives me negative 7/43, in fact. Okay, and that has got to equal e to the minus 0.07. Okay, 0.07t. Now, when I come to solve that, it's not possible, because if you think of the graph of e to the x or e to the minus x, neither of those will ever come below the x-axis. Okay, so I can conclude that that has no solutions. Okay, no solutions, since, and I just need to perhaps qualify that by saying no solutions since e to the minus 0.07t is greater than 0, okay, for all values of t. Okay, so I'm just qualifying that conclusion I've made. Okay, so you can also see that it wouldn't be valid for anything where theta is above 69.6. So no solutions. So so model not valid. Model not valid. Okay. For theta that is greater than 69.6. Okay, because of that negative result that's going to happen. Okay, and that is the conclusion I would make for question B. Okay, now finally we have the last question on the paper, question 14. Okay, so any natural number can be written as in any of these forms. So any natural number, okay, so a natural number is an integer, a counting number, 1, 2, 3, 4, 5, and so on, can be written like this. Okay, can be written. And I'm just going to take 3 examples. We're going to have 3k minus 1, 3k, and 3k plus 1. Okay, now I could have used any other 3 consecutive numbers, but I'm going to use those 3 because they're going to be easiest to work with because of the minus 1 and the plus 1. All right, and you could carry on that list if you wanted to. Now let's just take the first one and square it. So 3k minus 1 all squared, okay, is going to equal 9k squared. Okay, 9k squared minus 6k plus 1. Okay, and that in turn can be written as 3 lots of 3k squared minus 2k. In other words, I'm showing that it's a multiple of 3, but with a remainder of 1, you see. Okay, and I'm just going to state that. So that's a multiple of 3, multiple of 3, it's a multiple of 3 plus 1. I put the comma there just to separate that, because it's not a multiple of 3 plus 1, it's a multiple of 3 with 1 added at the end. Okay, and then I'm going to do the same thing with the 3k. That's easier, okay, because 3k all squared is just going to equal 9k squared, okay, which is equal to 3 lots of 3k squared. See, I'm actually going to write it like that, and then I just need to say that's a multiple of 3 without 1 added, multiple of 3 full stop. Okay, and then if I do the same with 3k plus 1, okay, which is my third form of the number, that's going to give me 9k squared plus 6k plus 1, okay, which is going to give me a similar result to the first one up here. That's going to give me 3 lots of 3k squared plus 2k, okay, plus 1, which is also a multiple of 3 plus 1. Okay, now all you need to do at this point is put a very minimal conclusion, and it really is minimal. You hardly need to write anything. You just need to show that you've got accurate results for all 3 cases, and then you can use this classic QED, okay, Latin, quantum erat demonstrandum, or quite easily done, and that's it. They're accepting that as your conclusion because you proved it, you've shown it very clearly. Okay, and that's the end of the paper. Okay.